So I want to talk about the why. Why do we need an inverse, and why do we even need logarithmic functions? So this is the reason. We can take 2 and raise it to the second power and get 4. And we also know that 2 raised to the third power is equal to 8. But what power could we raise 2 to the power of and get a 6? We can't solve for this x when it's stuck in an exponent. But with logs and our ability to rewrite from exponential form to logarithmic form, we can actually solve for x. So right now, this is a question mark. And I can see that it's got to be somewhere between a value of 2 and 3 because 6 is between 4 and 8. So let's look at the two forms of our expression. So in exponential form, we have the equation b raised to the x power is equal to y. That same function written in log form is log with a base of b, so that's like a little subscript b, of y is equal to x. Make yourself a note of how to read these. You want to say them properly whenever we talk about them in class. So you read it as log base b of y equals x. And a lot of times we'll have numbers plugged in for some or all of those. Here's how you can easily remember how to change from one form to the other. It's called the swirl. And so here's what we do. I'm going to do it a couple times so that you can see it and practice it. We start with the number on the far left and we swirl or make a circle around it. Then we head all the way to the right and we swirl across that and then to the center. So left, right, center. Notice that if we wanted to take this form and write it in log form, b is the first variable or possibly number I'm going to come across. So this b on the left becomes this. Swirl to the right, the y goes next. Swirl again to the center, and that's on the other side of the equation as an equals x. The same thing works in reverse. If I want to go from log form and write the same equation in exponential form, they are equivalent, I swirl. Left, right, center. It's almost soothing to just have that nice smooth pen or pencil stroke there. And so this is an easy way, again, to go the other direction. Notice that b, the number we circled first, is on the left. Then we circled x, so that comes next as our exponent, y on the other side of the equation. Let's practice doing the swirl to rewrite some log expressions into exponential form. Remember, I need a base raised to an exponent and then equal to something on the other side. My base will be 2, exponent for other side 16. So 2 to the fourth power is equal to 16. Let's try another one. 12 to the first power equals 12. 12 to the first power equals 12. Now these are things that we can kind of check, right? 2 to the fourth power, well, we know that 2 times 2 times 2 times 2 is 16. We also know that any number raised to the first power is just that number, so 12 to the first equals 12. That makes sense. Here's another one. 1/4 to the negative 1 power equals 4. So let's write that one and then think about it. 1/4, a fraction, raised to the negative 1 power is equal to 4. Well, if you remember our negative exponent rule, it says that if we have a negative, we take the reciprocal and make it positive. So the reciprocal of 1/4 is a 4, and the negative 1 becomes a positive 1, and that's implied here. So let's go ahead and box these as final rewritten expressions. Now we're going to do a base of e. Remember that we learned about the natural base last class. So in order to rewrite, I'm going to swirl again. E to the 0 power is 1. E to the 0 power is 1. Well, that makes sense because remember our 0 exponent rule, any number, it doesn't matter if it's an E, if it's a 1, if it's a 1 million, any number raised to the 0 power is always 1. That was one of the rules we learned back in chapter 6. Why don't you pause the video and try these last two on your own, come back here and double check how you did. All right, when you swirl this one, the number on the left is 6, on the right is 3, center is 216. 6 to the 3rd power is 216. 7 to the 0 power is 1. Well, not just 7, but any number to the 0 power, again, is equal to 1.